Welcome to the BackSteroids screencast. In this screencast, I'll attempt to teach you how to use this framework. This framework will give you an entire solution to create a mobile application for Android or iOS using the amazing platform from AppGyver. AppGyver Steroids gives you really a powerful solution to use native UI to create mobile apps. The one thing that I'm not a big fan of is Angular, which it uses for some of its documentation. Angular, in my opinion, got it all wrong. It mixes the business logic and presentation, relies heavily on different components that does just way too much magic for you that's hard to debug, and it's just slow. It's not really designed, in my opinion, for mobile. Backbone, on the other hand, is unopinionated. It's extremely fast. So with that, let's go ahead and jump into some of the things we'll cover. We'll use a global setup file that gets loaded by all the views. A view is basically almost like a tab in your browser. So when you're using a mobile app, you have different views. You can have, for example, a login view. You can have a settings view. So it's almost just like a screen in your mobile app. So we consider this a view. I'm not going to go to the detail of teaching how to use Backbone. I'm assuming you already know how to use Backbone. So with a view, since you're using this in a mobile app, each view is essentially a different tab, almost like a browser. So the inner communication between those tabs is not very straightforward. And so what we've done is we're using a local store as a plugin, and the local store allows us to share models like you normally do in any application. So this is very powerful. Simply create a Backbone model, save your data to the model, and then all the other listeners to that model will receive the changes. And of course, these listeners to the model could be on different views or different areas of your application. Some of the other things we'll cover is using require.js, using some trickery, so you can just use one require.js and load just the modules that you need per view. Again, reminding you that the view is almost like a separate website. So you need a way to share the require.js init file. So we'll cover that. We use Stickit for MVVM or two-way binding, so that's also part of the framework. Also, we are using a really nice library called StackView. StackView allows you to create GPU hardware accelerated fades and slides within a single view, something that you don't get by default with AppGyver Steroids. So it gives you really nice native slides and different type of animation between views, but not within a view. So StackView delivers that. We support localization. Of course, you can map the language from the globalization of the device and just pass the variable into our localization library, and you'll be able to change the language within the HTML. Cores is important since you're dealing with cross-domain and you're working within a sandbox. So the cores you need actually pre-flight. So I'll show you how to create, if using Node.js, pre-flight checks so you can actually talk to a server. And CombBroker is a moderator that allows you to communicate within a view and also send events between views. Again, views being almost like different tabs. So we'll cover some of that. The other things that we cover in this is just some general utilities like log and JLog, error catching, and the structure of the application. To me, that's the most valuable lesson in this screencast. It's just the overall architecture of the application. It uses a pure object-oriented type of design, separation of concern, really nice layout, so you can really create an application you can grow with. So I'll cover all this, and if you have any questions at the end, of course, you can always shoot me an email, and I hope you enjoyed this. So let's begin. So to get the framework and get your sample app running, I recommend you go to the GitHub repository and just download the zip file. Once you download the zip file, you should go ahead and just create yourself a project using the steroids create project command. Make sure you select single page app and make sure you select JavaScript and press enter, and this will create a brand new clean project for you. Once you've done that, you basically want to download the zip file I just showed you and then overwrite the directory structure with the content of the zip file from GitHub. So it's really easy to get up and running. So first, I'll give you a quick demo of the application. I'm going to use the simulator and show you how the application works and just the different components of it, and then we'll jump into the code. So here I'm in the Genymotion emulator for Android, and this is the application right here. Not very attractive, but it's not really meant to be. It's meant to be more functional. First thing we'll do is we'll change the language from English to Hebrew, and you can see that we can change all the context of the application. Go back to English. Next, we'll go to the animation view, animation page, and we're using the GSAP library, and that gives you hardware accelerated, super smooth animation. And I recommend you check out the green sock but it is part of the framework because again, if you're using with mobile and you want any kind of animation, green sock is the way to go. So that's part of it. Next, we just are binding here clicks, nothing fancy here, so that works. This is the stack view library, so you can see that we get again hardware accelerated, super smooth view changing within a single view, within a single page. So that's part of the framework as well. Same thing, but this time with fades. Again, hardware accelerated. So stack view actually uses the GSAP library. Okay, we'll go back. Here we demonstrated we can talk to the server and there's no security box. So we're just getting the server time and that works fine. We can send pings. So if I click on send ping, demonstrating the communication between the views, just sending ping. So if I click this several times, go ahead and open the log. You can see right here the pings are replying, just logging it. Next, I'll demonstrate how we can actually share models. So you can see right here I have a couple of fields, and go ahead and type in AAA here and BBB. And we'll go ahead and switch to the communication page where we have more fields, and you can see that the information propagated to the other view. Now again, this is just showing you that we can actually share models, backbone models between views, and you can see that that's working good. Go over here, go ahead and put in CCC. Again, switching back to the communication page, you can see that that propagated. However, you can also save this model to the server. So if I take this model and just save it to the server, in fact, let me go ahead and add a few more characters, go save the model to the server, and then switch to my other view. You can see that again, even though I saved it to the server, the information got propagated over. So this gives you an entire framework, everything that you pretty much need for an application. The ability to share models, some animation, hardware accelerated within a view, drawer right here, and the drawer uses stickit for MVVM. We also have an internet page right here, just embedded, nothing special there, as well as a settings page where we can toggle the tab bar and a dialog. So with that, let's go ahead and jump into the code and go to the structure of the application. I'm in the BackSteroids directory, so everything is kicking in, no errors, that's good. And the first file that we're looking at is our init.js. This is the required.js initialization file, and you can see we've set up all of our modules. We have our components right here, as I showed you earlier. We have our TwinMax. This is all the GSAP that we use for the animation. So these are the libraries right here. We also have the stickit for the MVVM. We use the backbone local storage so we can share models. We have our setup file, which I'll cover in just a sec. We have our backbone views. We have our backbone collection and models right here. This is our communication broker library. We have different elements for each page, each view, and I'll cover those. And last but not least is our stack view. That's the library that allows you to change the actual divs within a single view, within a single page, and have this fade animation and slide animation. If you scroll to the bottom of the page, you can see that we're kicking off the initializer using this variable right here called window.webviewer. So you may be wondering, where is this window.webviewer coming from? Well, if we go over here and scroll down to the actual pages of the application, so we have our index.html. Of course, this is where things kick in through the main file index. And then we have 5 more pages, so a total of 6 pages. So if we switch to the index.html, you can see right here that things kick off with this window.webviewer. This variable gets set, then init.js gets called from require.js, and this file name actually maps to a module. So every page will load its own module using the same init.js file. So the index.html will be the index, settings.html will load the settings module, the com page, for example, will load its com page module. So essentially we're sharing the same required.js initialization files through all the pages. Each one loads its own instance. All the pages have this catch all, and so this will allow you to see all the errors that actually occur when you're developing. The catch-all will simply catch all the errors and show them as an alert. Of course, if you release the actual app to the iOS App Store or Android, you don't want to show any errors to the user, and so you can disable this through the setup file. The setup file is another file that gets shared by all the pages, all the views. So if we go over here to our JavaScript directory and we have this setup.js, this is where things get set up when everything kind of kicks on. You can see that we're setting some global members, and you see here the Windows debug. That's where you'll see those alerts if errors occur. So you can of course disable this if you're going to release the app out to the wild. But while you're developing, you can keep this as one. This setup.js gets loaded for each instance of required.js. Next, let's review the structure of the application. You can see that we have the index.html, the root, and then under the pages, we have all the rest of our pages. And for each one of the HTML pages, we have a corresponding controller. The controller sits on the root of the JS directory. So we have the communication page, the cool animation, index.js. These are all the controllers for the corresponding HTML files. So where do we load those controllers? Well, I showed you earlier, but I'll review it again. If we again, for example, go to the index.html, you can see that the controller gets defined right here, where require.js will initialize it. If we go, for example, to our settings.html page, just like before, you can see right here that the controller is defined, and so it will instantiate our settings.js. So this is how everything gets fired up. Next, let's talk about the elements. You can see that right here I have an elements directory. This is nothing more than just mappings between HTML IDs and actual variables that hold the IDs. The reason why we want to do this is so if we actually wanted to change an ID in the HTML, for example, you wanted to change this to view123, you didn't have to go and search for all the places in the code because you keep on referring to a variable rather than the ID. Also, I'm using IntelliJ, which makes it very convenient to find the actual usage, so I don't have to look for this string. Instead, I can just right click on the assignment, go find usage. I can find all the places where this is being used in the code, and I can go directly to it. You can see how we are referring to it as in backbone.elements and then the actual variable right here. If we go back to the top of this page, you'll see that again we're looking at the index, so we're using the elements. I'll go ahead and switch maybe to a different page just to prove to you that we are using this throughout the application. So maybe go to our cool animation page. You can see that it again uses the cool animation elements, and we are instantiating it and again putting it under backbone.elements. Remember that you have essentially multiple applications, multiple views, each one being its own application, and each application, each view will just simply load its own elements that correspond to the view that it handles. Next, we're going to look at page view. Page view is our base class. It's the class that we extend from to create backbone views that represent the actual steroids view, the steroids pages, such as the settings and the cool animation that I showed you earlier, the different pages in the application. And so we have a backbone view that represents those, and it subclasses the page view base class. So in this base class, you can see that we have different functionality. The most important is the initialize page. The initialize page will actually create the supersonic view for you. And notice that it needs a location and the page ID, and those get passed in. So if we go to our index.js, and we have a function called init pages, initialization pages, that's kind of where we're creating the pages. We're just creating two pages, the cool animation and the communication pages. And we are passing an initialization of false, meaning that we don't want to run the code, we don't want to run the init code inside those classes. We just want to create representation of the initialization pages. And why do we do this? Because we want to be able to push this cool animation view into the layer stack to have it slide into view. So if we look over here, you can see that we're using this instance of this view to push it anytime somebody clicks on the go to main page button. So if we're not really initializing any of the code, we're just using this kind of a pseudo class just to be able to get to the location ID and the ID of the page, then when do we actually run the code for this class? Well, that's a good question. We do this over here. If I go back to my controller, again going to cool animation in this instance, you can see that over here we are also instantiating cool animation view just like we did the index.js, but in this case we are passing it the body and we are telling it to initialize the page. So in this case we are running the full functionality of cool animation view. In other words, if we switch into views and look at cool animation view, you'll see that this function initialize will get called from the base class of page view, and we'll go through all the initialization and do everything you need to do, really just all standard backbone stuff. Now if we switch to our cool animation view, you can see that we define the location and the page ID that we passed earlier, so steroids know to which HTML page to connect this particular view. Next, we're going to look at this collection right here, the local collection. This special collection allows us to share models across views. So what happens is anytime you save the model, it gets saved to the local storage. We use the Backbone local storage plugin for that. So anytime a view changes the model, it gets saved to the local storage, and then we notify through the notification system that a sync has taken place, a save, so other views or other areas of the application in different pages can listen to the event system and be able to pull the models from the local storage, allowing us to share models across views. So briefly looking at the code, you can see that we have this listen to all my events, and this special function, what it does is it uses our COM broker Fire Web View system to essentially create an event. This is a special URL that each collection has, and the way you can think about this is that let's say you have a collection on view A and you have a collection on view B. These different views, they want to be able to listen and share this collection, or rather the models within the collection, so they need to be able to hook into the same URL. So if we switch over here to our index.js, you can see that we're creating, for example, here a collection, and we're creating a model, and we are passing in this special URL called cat. So this is done on the index.js file. Now if we switch over to our communication page, we can see that we're instantiating the communication page view. So let's go ahead and go to our views and look at our communication page view. And sure enough, we're doing the same thing. We're using the same collection and using the same URL. And so this connects the two collections from the two sides of the application together, so they can listen to one another. So here, for example, I'm just adding a node, which is just a model, a backbone model, and then I'm saving it. And as soon as I save it, the other collection would get notified and would be able to act upon the new changes of that model. Now the real magic happens in the save, because remember, just saving it to the local storage is not enough, because the other collection on the other side of the application is not going to get notified. It doesn't know that the local storage has been changed. So again, this is where we notify the other collection through the event system that something has happened that it cares about and it should act upon it. And of course, we are also fetching it. We don't have to, but I'm just showing that we can also fetch the content from the local storage. Now switching back to my index.js, I'm not sure if you guys paid attention, but we're not using the local collection, we're using the authentication collection. And so what authentication collection is really nothing more than just a subclass of local collection, so it's the same thing. However, in the authentication collection, we've implemented our own onSync. Why do we do this? When things change, it'll call the onSync. This is really the function that you care about, but you can see that this is just an abstract function. It doesn't really do anything. So it's up to you, the developer, to create your own onSync. So when something happens or changes, you want to act upon these model changes, so you're going to implement your own onSync. So if I switch to my auth collection, so I've implemented my own onSync. And so what I do here is, remember that I'm using this auth collection 3 times. So if I switch over here to my communication page view, as I showed you earlier, I'm using authentication collection 1, auth collection 2, auth collection 3. So essentially I have 3 collection, each one for cat, dog, and lion. And so what I did over here, I just did a simple switch statement depending upon how this authentication collection was instantiated, and I simply fill the fields in the HTML DOM with the correct data. So the local collection is a really powerful collection system that allows you to share its data through the local storage and notify through the communication broker when changes, especially on sync, taking place. It also has another really cool feature, which is the ability to save the model to the server as well. So if you go back to our local collection, you can see that it has a function called save to server, and with this method we're able to switch a flag, save the collection, or the model rather, to the server, and then switch it back on and share the model across the other pages. So if we go back to our index.js file, you'll notice over here that what I do is I go and I create my model. But if we look at this model, the node model, go ahead to my models, you see that I have a URL root set on my model level. So this is where we're going to save our model to the remote server. And so what I'm doing here is I'm just creating the collection, I'm adding the model, and I'm saving it locally. But then over here I got this function right here, save to server. And so what I do here is I execute save to server, true. So from this point on, the saves are not going to go into the local collection. Instead, they're going to go into the remote server of the URL of the model. And then on the success, I just basically just show the date to the user. And then when it completes, regardless if it was successful or error, I go ahead and I set the collection to save to server false. So from that point on, all the saves and all the communication on that particular collection happen internally within the application. So you don't have to duplicate your model system. You can use a single model system within your application, both for inner page communication as well as server syncing. Next, we're going to look at the stack view. Remember that I showed you earlier that with a stack view, you can scroll kind of like a carousel, but it's hardware accelerated, GPU powered. So you have super smooth transitions, both fades and scrolls, like a carousel. So if we switch over to our cool animation view, you can see that we have the fader container, which again is just an instance of the stack view fader. And then we create 3 vanilla backbone views, nothing special about them. We add the views to the container, and then on the click we're able to select the view right here. So it's very simple to use and yet gives you very good performance. Also using the same type of stack view, but this time for a carousel. So you can see the same thing here. We basically are creating the stack view, but this time the slider. With the slider you're actually able to select the IDs from the element and 2, from element and 2, and from element 2 because we have 3 views, 3 backbone views. We add the 3 views into the slider container, and then you can see that we're doing the slide to page. All the magic really happens in CSS. So switching really quick into the CSS, go to style sheets and go to application CSS. You can see that right here we have our pages. This is where we're using the GPU hardware acceleration. For the fader view, where you fade in and fade out, we actually use the GSAP for hardware acceleration there. So it's not done through CSS, only done through CSS for the sliding left and right. Looking at the index.js, you can see we also have support for localization. As I showed you earlier, we use this component called language selector view, and switching to it, you can see that we have right here the data localized tag, and we're setting the localized whatever language. The translation languages are actually set over here under language. So you see we have the translation file right here for English and for Hebrew. And so of course you can build these, and we actually map these in the HTML file. So if I select one of these and switch into my index.html, you can see that we have the data localized, so you can actually map the strings, in this case go to animation page. So that's all pretty straightforward to set up. In the library file, we have useful functions such as log, which will just log to the console. Also, you can JLog, which will basically log your JSON objects, so you can parse your JSON object through the log file. There's other things that you can check out, like the add backbone options, which has been removed in a recent version of Backbone, so we're adding it back on since we need it. So this is a nice utility library I recommend you just go through. And the last thing I wanted to mention, as I promised you, is just how to set up the server. So you do need to install the Cores plugin. You can get it through npm. So make sure you do that so you can actually communicate with the server and not be blocked by a security box. And in the actual calls, this is pretty unique. I'm not sure why you have to do it this way, but you do need to do a pre-flight. It's probably because you're dealing with an application that doesn't download the HTML files, so the Chromium browser is probably upset. So for that, you actually have to set up a middleware that's in line with your functions. If you do it globally, it doesn't seem to work, but if you do it in line through the middleware of every CRUD call, that does seem to work. So that's just one valuable tip that you want to set up on Node.js if that's your server side. So this wraps up this screencast. I hope I didn't go too fast. I gave you just a taste of what's going on with this application. There's a lot more things that are going on. I actually recommend you read the source code. The beauty of this is that everything works really well. It's very easy to set up. I think AppGyver are really onto something special. They've really taken Cordova to the next level. You get native component, really beautiful performance. Again, Angular is not my cup of tea, and I think with this application here through Backbone, you really get the best of both worlds. You get the beautiful performance of AppGyver, and now you get just a nice framework that allows you to pretty much deliver in a professional application, professional mobile application that really does everything any other application can do. I hope you enjoyed this screencast, and let me know if you have any questions. Thanks.